Desiring machines and affective virtual environments. Language is closely related to how we perceive ourselves and signify our reality. In this scope, we created Desiring Machines, an interactive art project that promotes the experience of affective virtual environments adopting speech emotion as the leading input source. Users can express their emotions by speaking, singing, reciting poetry, or making vocal sounds to create an audiovisual representation in virtual reality using a head-mounted display. The contributions of our research are of technical, practical, and critical nature. Aylett and Cavazza first described the intersection between artificial intelligence and virtual environments as intelligent virtual environments. There has been an increasing interest in developing intelligent virtual environments in many fields. Remarkably, there has been a continuous interest in automatic speech recognition technologies for virtual reality applications. In 2002, Levin and Lieberman presented an augmented reality speech visualization system named The Hidden Worlds of Noise and Voice. The project allows users to visualize the voices of others, which are exposed in the form of animated graphics emerging from the mouths of the users while speaking. The graphics representing these expressions assume various shapes and behaviors associated with basic characteristics of the vocalist's volume, pitch, and timbre. Mays and her team at MIT present a system named Auris that automatically generates VR environments from music. As input sources, they propose using songs, audio, and lyrics to produce a VR world that encapsulates the mood and content of the song in the space design. Using creative licenses, they decided to transform the generated virtual landscapes into psychedelic and surreal places by pre-processing textures that are applied to objects through the Deep Dream neural network. In 2021, Penilla et al. Suggested an association between features of audiovisual elements and affective states. They propose guiding cues to develop virtual environments that automatically create visual representations of users' affective states, analyzing their electrophysiological activity. Our proposal includes a speech emotion recognition system and a strategy to map predictions into virtual environments. The main technical novelty is the adoption of two machine learning models to predict emotions from semantic and acoustic features. To capture the information's context, we built a long short-term memory network architecture. The algorithm was trained with two databases containing poetry and film reviews annotated with positive and negative labels. The network was trained to minimize the categorical cross-entropy loss function for 4 epochs with an accuracy of 88% on a validation dataset of 150 new text files. We propose a convolutional neural network for the acoustic counterpart to predict emotions from the audio clips recorded and temporarily saved in the CPU. We have used 3 different datasets to train the model. A combination of spectral acoustics features was extracted from all the audio clips to generate the input vectors. These vectors were passed through 4 one-dimensional convolutional neural networks that output the feature maps using ReLU activation functions. The network is trained by minimizing the categorical cross-entropy loss for 100 epochs in batches of 64 files, with an accuracy of 81% on the testing dataset. To transfer speech emotion to music, we use a computational model to create chord progressions based on consonants and harmonic dispersion in the tonal interval space. The graphical environment is built using a text-to-image API provided by Deep AI. This image is scaled and used as a style source transferred over an equi-rectangular projection image chosen for each emotional category. The artistic result is an immersive virtual space encapsulating emotions in spheres disposed into a 3D world. Users can create new affective representations or interact with other previously encoded environments using the joysticks. The user interface is composed of a head-mounted display and two joysticks. The head-mounted display is equipped with a lens, headphones, and a microphone. The device is connected to a central unit where speech is processed. The user interface also proposes publicly sharing a stream from the user's point of view. Deleuze and Guattari explicitly question the psychoanalytic and structuralist conception of desire. In Anti-Oedipus, the genealogy of lack is relegated to the detriment of the post-structuralist conception of flow. Thus, they assign fundamental importance to lack by giving it a creative capacity. In What is Philosophy?, Deleuze describes how this creative process produces something new, namely affects and percepts. Artistic creativity generates new affects and percepts and combines them into blocks of sensations. These blocks then form the basis of our experienced reality. For the French authors Deleuze and Guattari, desiring machines are the site of that production.